Hello, my name is Andrej Sulek, and I will be presenting on the lab findings of Lab Group B2 in the Laboratory Experiment 4, which was conducted on the combustion dynamics in a Rijke tube. I will start off the presentation with giving a little background information and motivation about the Rijke tube. Then I will flow into the experimental setup, which will then turn into some data analysis and data results to see if our findings were supported by our experimental observations. Start off with the background information. What is a Rijke tube, you ask? A Rijke tube is this hollow metal cylinder. It can be of varying heights with a metal mesh inserted about a quarter of the length inside the tube. Both these things create a pulse combustor. I would like to highlight and contrast a few differences that we can find between a pulse combustor and a steady state combustor. What a pulse combustor does is it uses three different things, which are the heat, the pressure fluctuation, and the velocity oscillation to create a continuous cycle which mixes the propane and the air properly and allows for a more ideal combustion. Because these three things are so important, these three things were also measured in our experiment, which were the pressure, the reaction rate, and the flow rate. Now that we've gotten a little bit of background information, I would like to move to the experimental setup. The way the experiment was conducted in the Engineering Science Mechanic building in the room G2, where we have a combustion laboratory and where the Rijke tube is situated so we could conduct experiments on it. The three quantities I mentioned previously were measured using a piezoelectric pressure inducer, which was used to measure different pressure fluctuations within the tube. The next measuring device used was a photomultiplier, which was used to measure the reaction rate and intensity of the combustion process. Now the way we quantified this was we quantified the rate at which the propane was consumed and the amount of heat that was released. The last measuring device used was a rotometer type flow meter, which was measuring the fuel flow rate. Before we started the experiment, the Rijke tube needed to be flushed with air to prevent any explosions because it could have been filled with propane, and when we switched it on, we didn't want any material damages to occur or for us to damage the Rijke tube. Then tests were conducted at three different burner heights with valves either open or closed. The heights were specifically 0 inches, 2 inches, and 4.8 inches. And what we were listening for were different audio cues of when the pressure fluctuations started and stopped. Now I'd like to move on to the data and results. Initially, what we did was measure the Rijke tube length, which was then used in further calculations, and we varied the burner height, to test that at which height the audible cues stopped, which we found that it was at a burner height of 4.8 inches. Two slides contain raw data just for consistency's sake, so you can backtrack our calculations, and so I will skip over much. Then we get to the data reduction part of this lab. As you can see, the equations on the screen were used to determine different properties and to reduce the data into some meaningful data that can be interpreted. We used a relationship between the amplitude and the frequency, and then through which we found the resonant frequency of the Rijke tube, which is determined to be around 88.86 Hertz. These data reductions and the formula that you can now see on the top right of your screen of this slide presentation were used to actually convert the root mean square voltage into the decibels that can be seen on the screen now. One thing I would like to highlight on the screen is that you can see that at 4.8 inches of burner height with the valves closed, we can observe that the decibels were consistently the lowest measurement and fluctuated from around 105 to 110 decibels. The next slide illustrates the relative phase angles, which were normalized over the PM, which you can see was taken at the sensor location of P2, which is why that entire row contains zeros. And in summary, the experimental data supports the real-time observations of the pressure fluctuations. I would like to stress the importance and advantages of impulse combustors, which were that the heat, pressure, fluctuations, velocity oscillations produced a continuous cycle that aided combustion. This proves that Rijke tubes are a relevant topic to explore and implement in the aerospace industry. Thank you very much for your attention and have a nice day.